Good day, grade 12 learners. Welcome to Physical Sciences Chemistry lesson. My name is Thandwe Uwane. This lesson is proudly brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our today's lesson is going to look at the rates of reaction, which is one of the topics that we do in chemistry, grade 12. Now, don't forget to WhatsApp us in terms of interacting with us in this number 064 748 8913. We will try by all means to respond to your WhatsApp, even though it might not be in this lesson or during the lesson, but we'll definitely make sure that we try and respond to your questions. Now, as I said, that today's lesson is about the rates of chemical reactions. Now, the first thing that you need to know the objectives of the lesson according to the exam guideline. Remember, we are always referring to the exam guideline that is stipulated or provided to us by the Department of Basic Education. Therefore, we are going to look at the bullets that you need to know before you sit for your exam under this topic of rates of reactions. Now, let's look at the objective of the lesson. The first thing that you need to know, we need to define rate of reaction or reaction rate. We also need to calculate the reaction rate from the given data. I think we already know, or we have already noticed that most of the time when we start a topic, we definitely have to deal with the definitions that are in that topic. Therefore, the first thing that you need to know how to define. Therefore, we are also going to list the factors that affect the rate of reaction. We are not going to list them by one in terms of the examiner asking you, but you need to know those factors that affect the rate of reaction. And those are the factors that are very important for you to understand in terms of this lesson, because they're the ones that we are going to discuss into details in terms of how do they affect the reaction rate. We are also going to explain the collision theory on how the various factors affect the reaction rate or the chemical reaction. And then we are also going to answer and interpret data. Data can be given to you in terms of tables or graphs on different experimental techniques for measuring the rate of given reaction. So it is very important to know how to interpret data that you are provided in your exam. You are also going to define a positive catalyst. We are only going to define a positive catalyst because the rate of reactions that we are going to look at, you are going to only look at the factors that increases the rate of reaction. So therefore, it is very important that you only know the positive catalyst, because we are not going to look at the factors that will decrease the rate of reaction or that will slow down the rate of reaction. We are also going to interpret graphs or distribute of molecular energies in terms of the particles against their kinetic energy or Maxwell-Boltzmann curves. So therefore, as we are going to start, these are the things that by the end of this lesson, we need to make sure that we understand. Then, what is the pre-knowledge of this lesson? We know that for every lesson to be understood, there is something that we've done in our previous grades that will assist us to understand the topic that we are busy with. So the pre-knowledge that we are going to look at, the types of reactions like exothermic reaction. We need to remember what is exothermic reaction. We need to remember what is endothermic reaction and also kinetic energy, because these are the terms that we'll be using more frequently in this lesson. What is this exothermic reaction? We remember that exothermic reactions are reactions that release energy. Endothermic reactions are reactions that absorb energy, and kinetic energy is the energy of an object possesses as a result of its motion. So these are the pre-knowledge concepts that we need to understand before we continue with this lesson. What else do we need to know in terms of this reaction? Remember, we are going to deal with chemical reactions. Therefore, we need to understand bond energy, the energy that is needed to break one mole of its molecules into separate atoms. We also need to understand what is a bond length, which is the length between the distance between the two nucleons of the bonded atoms, and also the activation energy. The activation energy is the minimum energy needed for the reaction to take place. So as I was explaining, I tried by all means to also give you this definition so that you remember exactly what is it that is expected of you out of this definition, and also remembering the concept, because these are the concepts that will assist you to understand the reactions that you are going to deal with, and also the other concepts as they are growing from one grade to another. We are also going to look at the chemical reaction now. What is the chemical reaction? I think that is the main thing that we need to understand, because we are going to look at the factors that will affect these chemical reactions. Therefore, you need to know what is a chemical reaction. For every reaction to occur, the first thing that you need to have are the reactants. The reactants are the ones that will determine the reaction, because without reactants, there won't be any reaction. So as the reactants are going to react and they are going to be converted to products, that's when we say we have a chemical reaction. So chemical reaction is the process in which reactants are converted to products. It is very important that you understand that the first thing that you're going to have in your chemical reaction, you will firstly have the reactants. And at the beginning of the reaction, there won't be any product. Therefore, when will the product form? The product will form after the reactants are converted. So the first thing initially, you will only have the reactants in a chemical reaction that will be converted to products as the reaction processes. Now, during the chemical reaction, the existing bonds between reactants will be broken down and the new bonds will be formed. So you need to know that as the reaction occurs, it means now the existing bond between the reactants, or between the particles of the reactants, or between the bonds of the reactants will be broken down. And as a result, the new bonds will be formed. The new bonds will be formed when the products are starting to form. So what will happen? Particles of different reactants will collide with each other. However, what type of collision must occur for the chemical reaction to occur? There must always be an effective collision with sufficient energy for any reaction to occur. And that sufficient energy that we are referring to in this regard, we are referring to activation energy. Activation energy is the minimum energy, as I said, minimum energy required for the effective collision to occur. The particles of the reactants, even though they can collide, but if the sufficient energy for them to have an effective collision is not available, it means no chemical reaction will occur. Therefore, you need to know that for any chemical reaction to occur, we need effective collision that will be provided by the sufficient activation energy. Now, let's look at the definition of reaction rate. What is this reaction rate? Reaction rate is the change in the concentration of the reactants or products per unit time. I have underlined two important concepts. I have underlined the change in concentration, and I have also underlined per unit time. So it means what is important is that you need to know that for that reaction to occur, there must be a change of the concentration of reactants or products. How will the concentration of the reactants change? That is the first thing that you need to ask yourself. Definitely, in a chemical reaction, you will expect the concentration of the reactants to decrease as the products are forming. And you will also expect the concentration of the product to increase as the reaction processes continues. So it is very important that you know that the change of the concentration is gonna be based on which part is formed. Like the reactants concentration, how will it change? The product concentration, how will it change? So what makes the concentration of the reactants to change? Remember, as the reaction starts, it means the reactants will start now changing and converting themselves to become products. So as the reactants are being converted towards products, it means now that the concentration of those reactants will decrease. And because you started by no products, it means as the reaction processes, it means now the concentration of the product will now start to increase. So as the change in concentration occur per unit time, that's when we're going to have the reaction rate. Now, the word per unit time, remember the units of time are per second, is second. Now we say those changes in terms of the concentration of the reactants in the product will occur per time. Per time is 1/2. So that is why we say per unit of time or per unit time. And if in your definition the word per unit time is not part of your definition, therefore you are not going to get the desired marks, because per time must be there for the change in concentration to occur. Now, we are also required to calculate the reaction rate according to the bullets that I have read under the exam guideline. Now, when calculating the reaction rate, the reaction using the number of moles, or we can calculate in terms of the mass, or we can calculate in terms of the concentration of the reactants. So if we want to calculate the rate of the reaction in terms of the moles or mass or concentration of the reactants, because what is important now is that we will be looking at the reactants. I just want to underline this. We are going to be based on the reactants. If we are now looking at the rate of reaction in terms of the reactants, we are going to use the following formula. We are going to say the average rate is equal to minus the number of moles or mass or concentration of the reactants per unit time over time. Or we can say the rate at which the number of moles or the mass or the concentration of the reactants will change. Now, if you can check in my equation or in my formula, there is a minus. Why is this minus important? Remember, we will be calculating in terms of the reactants. Now, I have already explained to you that as the reaction processes, what is going to happen is that the concentration of the reactants will decrease. What makes the concentration of the reactants to decrease is because the reactants are being used. And as the reactants are being used, it means their final number of moles will be smaller than the initial number of moles, because the concentration will be decreasing, the mass will be decreasing, and also the number of moles will also be decreasing. Therefore, it means now we are going to put the negative in order for us to obtain the positive value of the reaction rate. So this minus is when you are calculating for the reactants, the number of moles of the reactants, or the mass of the reactants, or the change in concentration of the reactants, because we know that the reactants, their concentration is decreasing, their mass is decreasing. Therefore, we know that if we put it as final subtract initial, our answer will be in a negative value. Therefore, we need to put this minus for us to have the positive reaction rate. Now, when you now calculate in terms of the products, when you want to calculate in terms of the number of moles or mass or concentration of the product, you will see that now we don't put a negative, because definitely our final number of moles or our final concentration or our final mass will be higher or will be greater than the one that we started with, because the products are being formed. In terms of the reactants were used. So that is why they will get a smaller number as the final. And if you substitute in the reaction, you'll find the answer being negative. But because the products are being formed, you will find that the final number of moles or the mass will be greater than the one that you initially started with. Therefore, the answer will definitely be positive. So it is very important to check whether you are calculating in terms of the reactants or whether you are calculating in terms of the product, so that you write the correct formula. And that negative is very important, because if you are getting your answer as the reaction rate as negative, it means something went wrong. It means you forgot that the number of reactants or the reactants are being used in the reaction. That is why the value becomes smaller. Now, we are going to discuss these factors that affect the rate of reaction, but we are going to look at the theory that we are going to use in order to say how are these factors affecting the rate of reaction. We are going to look at the collision theory. The theory states that 3 conditions must be met for the reaction to occur. What are those conditions that must be met for any reaction to occur? Already we know what is a rate of reaction. Already we know what is a chemical reaction. But what will make the chemical reaction to occur? Now, the first thing that we need to understand is that there must be effective collision, or the particles or the atoms or the molecules must collide effectively. For any reaction to occur, if there is no effective collision between the atoms or the ions or the molecules, the chemical reaction will not occur. So these are the requirements that must be met, firstly, for every reaction to occur. Secondly, we must have an energy which is equals to or higher than activation energy. I think I have already explained that activation energy is the minimum energy required for any effective collision to occur. Therefore, if the energy that you have for that reaction is less than the activation energy, therefore there won't be any reaction that will occur. But at least the energy must be equals to the activation energy or must be higher than the activation energy for the reaction to occur, because that energy will make those particles or those atoms or those molecules to have effective collision. Therefore, if the energy is less, it means we won't have effective collision. We need to make sure that the energy is sufficient for every reaction to occur. And what type of energy are we referring to? We are referring to activation energy. And then the third thing, because I said there are three factors that are needed to be met, or requirements that are needed to be met for any reaction to occur. We need to have the correct orientation of the colliding particles. What will the correct orientation do? The correct orientation will make sure that at the end, it will lead to the arrangement of atoms and the formation of the product. So if the particles are not having the correct orientation of colliding or of reacting, it means at the end of the day, we will not have the desired product. So we need correct orientation so that it can lead to the arrangement of atoms and the formation of the product. So we know already that the three factors that are needed for the effective collision or the reaction to occur, we deal with effective collision, we deal with sufficient energy, which is activation energy, and the thirdly is correct orientation. Now, let's look at those factors that affect the rate of reaction. It is very important that you understand these factors, and it is very important also that you understand how do they affect the rate of reaction. Remember, the rate of reaction will be affected by the way the changes will occur in that specific reaction. So let's look at the factors. As I said, we need to list them and know them by heart to say which factors will affect the rate of reaction, because sometimes another factor can be provided to you during the examination, and when you look at that factor, you can see that this is not the factor that we discussed. This is not the factor that can affect the rate of reaction. So it is very important that you know the list of those factors that affect the rate of reaction. The list is not in any order, but we are just going to discuss all the factors that affect the rate of reaction. Concentration of the reactant in a solution. So what affects the reaction, the rate of reaction, is the concentration of the reactants in a reaction. The reaction cannot be affected by the concentration of the product in a chemical reaction. Remember, the product will be formed after the reactant has reacted. Therefore, it means what you need to change, you need to look at the concentration of the reactants for you to affect or for you to influence the rate of reaction. We are also going to look at the addition of a suitable catalyst. Now, we are going to add, a catalyst is going to be added. We are not going to increase the catalyst. We can increase the concentration, but we can't increase the catalyst. What do we do in terms of the catalyst? We add a catalyst, and that catalyst must be a suitable catalyst. It is very important that you know that not any catalyst will function, but only a suitable catalyst. For every catalyst is suitable for every reaction. So we cannot use any catalyst in any reaction. You need to make sure that the catalyst that you are adding in that particular reaction can influence that particular reaction. Then we are also going to look at the surface area of a solid of the reactants. In terms of the surface area, we are only going to concentrate on the solids. We are going to change the surface area of the solids of the reactants. It's still under the reactants. So the concentration and the surface area that we are going to change is for the reactants. So it is very important that if it happens that you are asked, how can you influence or how can you change or how can you increase the rate of the reaction, and you are given the surface area or a solid, you know that you are going to increase the surface area of that solid. And we are going to discuss how do we increase the surface area of a solid. We are also going to look at the pressure. Now, in terms of the pressure, you must know that the reactants must be gases. So the pressure will only affect the reactants that are gases and not solids or liquid, because you can only be able to work with the pressure in terms of the gases. We are also going to look at the temperature of the reaction mixture. So in terms of the temperature, when you increase the temperature, you are going to increase the temperature, you are going to increase the temperature of the entire mixture. It's not only for the reactants, it's not only for the product, but it's the entire mixture. So increasing the temperature will affect both sides. And then we are going to look at also the nature of the reacting substances. Now, let's look at each and every factor. I said we are going to discuss this reaction, these factors that affects reactions, looking at the collision theory, looking at those requirements that we discussed in our previous slide to say how can the reaction be influenced, or what can we have, what is it that we must have for the reaction to occur. So the reaction rate increases when you look at the surface area, which is our first factor that we are going to discuss. I said in terms of the surface area, we're going to look at the solids, and those solids are going to be your reactants. So it means you are going to change the surface area of your reactants, which are what are solids. So the reaction rate increases with an increase in the surface area of the reactants. Now we know that as we are going to increase the surface area of the reactants, we are definitely going to increase the reaction rate. As I started this lesson, I said we are only going to look at the factors that increase the rate of reaction. So the increase in the surface area increases the rate of reaction. What is an example that you can use in terms of the increase in surface area? As I said that in terms of the surface area, we are going to look at the solids. Now, when you take a solid like chalk, you know, we normally see white chalks or colored chalks in our schools. If you take a chalk and you grind it and you make it a powder, you will see that the area that the chalk will occupy before you grind it is going to be less than after you have grind it. So it means before you grind the chalk, it will occupy a certain space. Immediately when you grind it, now it will start now spreading out. As it spreads out, we are saying we are increasing the surface area, meaning that the surface area of that particular substance will be larger. So what will the larger surface area do to the rate of reaction? The larger the surface area, or when you increase the surface area, you will increase the rate of reaction. That is why you will hear in some of the adverts that you normally hear, we know that we use, if you can ask to say, what do you prefer in terms of the tablets that are being grinded and the tablet that is a solid, like grandpa tablets? You know that grandpa work faster because it is powder. So it means that as the grandpa is becoming a powder, its surface area is being increased, and it will make the reaction rate to be faster, meaning that you will heal faster because the reaction that will occur inside you will be faster because of the larger surface area. Now, let's explain what exactly is happening as you are increasing your surface area in terms of the collision theory. Increase in the surface area of the reactants results in more reaction sites. So you are going to have more reaction sites because as they are spreading out, it means there will be more reaction sites. So that is exactly what is happening when you are increasing a surface area of a solid. And therefore, this will increase the number of reaction sites, increasing the frequency of total collision. So it means that now as you are spreading it up, it means it will make the more sites to have effective collision by increasing the frequency of the total collisions. And then there will be more effective per unit time. Therefore, the reaction rate will increase. Now, you will see that I will underline some of the concepts that are very important for you to explain when you are giving an explanation in terms of how will the surface area influence or increase the rate of reaction. Now, there will be more reaction sites. There will be increase in the frequency of the total collisions. There will be more effective collision per unit time. Therefore, the reaction rate will increase. I will be very happy if you can also use a bullet form or bullet way of answering these questions, because you will know exactly what is it that you have missed in your answer, because all these factors are very important. Normally, we give you 3 marks for such questions to say, how will this affect the rate of reaction? Remember, it cannot be how will the surface area affect the rate of reaction, but it can come as if what will happen if we grind this a particular solid, or what will happen if we increase the surface area of this particular solid, because these are experimental questions. They can be asked in a form of an experiment, so you need to know exactly what is it that you need to write down in terms of the increase in the surface area. So I will go back and say more reaction sites, and then increase in the frequency of total collisions, and then more effective collisions per unit time. Guys, these words are all important. Not effective collision but more effective collision per unit time. So you definitely need to know how do you respond in such questions. Now, let's look at our second factor. The second factor that we are going to look at is the concentration. As I said before, that which concentration are you affecting? You will increase the concentration of your reactants. So the concentration is the measure of number of moles of the dissolved solid per unit volume. How do we calculate the concentration? We know that from grade 11, we calculate concentration as C is equals to N over V, whereby we know that N represents the number of moles of a solute and V represent the volume of a solvent. That is why we say is the number of moles of a dissolved solute per unit volume. We already know that, if you have more solute than a solvent, you will definitely have a higher concentration. But if you have more solvent than a solute, you'll have a lesser a concentration. This will be further discussed when we are going to do our next topic, which is going to be our acids and bases, so that we can remember, because we also did acids and bases last year in grade 11, so that we can remember how do we calculate concentration and how can concentration affect our rate of reaction. So what you must understand is that the higher the concentration of a reactant in a solution, the higher the rate of reaction. Guys, this is very important that you know that the concentration that you are referring to is the concentration of the reactant. Because sometimes, because you'll be given a chemical reaction, you will sometimes be confused, which concentration must I increase for this rate of reaction to be faster? So you need to know that you will increase the concentration of the reactants to increase the rate of the reaction. Now, what is exactly happening if you increase the concentration? The increase in concentration increases the number of solute particles in a solution per unit volume. So the increase in concentration increase what? It increases the number of solute particles. And it will do what? It will increase the number of solute particles in a solution per unit volume. That is exactly what is happening when you increase the concentration. So you need to know exactly how each factor affects the rate of reaction according to the way I'm discussing it in a bullet form, according to the collision theory. And you also need to know that the increase, and then that will increase the effective collision between the particles per unit time, or increase the frequency of the effective collision, and therefore the rate of reaction will increase. So it is very important to know how each factor affects or increase the rate of reaction. Now, the temperature. The temperature can also increase the rate of reaction as one of the factors that affect the rate of reaction. Now, the increase in temperature will increase the rate of reaction. So we know that as you are going to increase your temperature in your chemical reaction, you will definitely expect the rate of reaction to also increase. Now, how does the temperature affect the rate of reaction? Or how does the temperature increase the rate of reaction? Particles can only react with their collision, which is effectively. So if we have effective collision, we know that particles will definitely have the increase in the rate of reaction. Now, higher temperature implies higher average kinetic energy of the molecules. So when you are increasing the temperature, what exactly are you increasing? You are increasing the average kinetic energy of molecules or particles, which are the reacting particles. So when you increase the temperature, exactly what is happening between the particles will start to increase their average kinetic energy. Remember, this is directly related to what you did last year, not last year, in grade 10, when we were looking at the state of matter, where you're looking at kinetic molecular theory. In terms of the kinetic molecular theory, we know that as the temperature increases, when we are doing those heating curves, we could see that now the particles, as they were in a solid phase, they were moving. Actually, they were not even moving because they were very close to each other. They were just vibrating. Immediately when you start to increase the temperature, you will start now to see that the average kinetic energy of the particles will start also to increase, meaning that the particles will move faster as before. So when you increase the temperature, you know that exactly what you're doing, you are increasing the average kinetic energy of the molecules. Therefore, more molecules have minimum energy or equals to or higher than the activation energy. So it means now more molecules will have enough energy, will have enough or sufficient activation energy for the reaction to occur. Therefore, more effective per unit time, more effective collision per unit time, and therefore that will cause the reaction rate to increase. This explanation, you can see they are not the same. Each and every factor affects the rate of reaction in a different way. So you need to know how does each factor affect the rate of reaction. So the temperature will do what? Will increase the average kinetic energy of the molecules, and making sure that there will be more molecules which have the minimum or enough activation energy, and therefore there will be more effective collision per unit time and the reaction rate will increase. So we have already discussed three factors that affect the rate of reaction. We started with the surface area, and we have explained how the surface area affects the rate of reaction. We went to concentration. Now we are busy with temperature. And the next one that we are going to look at now is the addition of a catalyst. As I said, we have increased the surface area. We have increased the concentration. We have also increased the temperature. However, in terms of the surface of the catalyst, we are not going to increase the catalyst. We are going to add the catalyst, and we must make sure that whatever catalyst that we are adding is going to be a suitable catalyst. So what is the definition of the positive catalyst? Because we are required to also define positive catalyst. Positive catalyst is a substance that increases the rate of reaction or the rate of chemical reaction by providing a different pathway or of lower activation energy without itself undergoing a permanent change. Remember, a catalyst for every reaction doesn't take part in the reaction. It doesn't change the energy of the reaction, and it is also not involved in that reaction. It will not be changed. However, the only thing, it will provide an alternative pathway for the reaction to occur by lowering an activation energy. Now, you must understand that the catalyst does not change the energy of the reactants or products, and also the catalyst does not affect the heat of the reaction. So the catalyst will only provide an alternative pathway by lowering also the activation energy. Now let's look at what exactly does the catalyst do in a chemical reaction. Collision only results in a reaction if the particles collide with certain minimum energy called activation energy. I think we've already discussed that. Adding a catalyst provides an alternative route with lower activation energy for the reaction. So, provides an alternative route with lower activation energy. And if you want to remember this, go back to the graphs of endothermic and exothermic graphs and look at the activation energy. Where do we read the activation energy? If we lower the activation energy, definitely we are increasing the rate of reaction because the particles will collide even more effectively. More of particles will now react via the easier catalyzed route with lower activation energy. So the particles will definitely choose the easier route, which is having a lower activation energy for them to occur, and then there will be more effective collision per unit time, and this will increase the rate of reaction. So we definitely know how does a catalyst affect the rate of reaction. It lowers the activation energy by providing an alternative pathway for the reactants to react. Now, in terms of the nature of reacting substances, we know that Different chemical reaction depends on the medium in which they are reacting, like liquids and gas, or the properties of the reactants. So in terms of the way the nature is, I will refer back to the chemical reactions that we looked at. You could see that when we were doing our previous topic, which was organic molecules, we could see that different compounds were reacting in a different way because of the different functional groups that they were having. Also, sometimes some of them were more polar than the others, some of them they were non-polar. So all those things, it depends on the nature of that particular substance. That is why we are saying then another factor that can affect the rate of reaction is the nature of the reacting substance. So the rate of reaction may differ depending whether the medium is an aqueous or organic or polar or non-polar or liquid or solid or gas. So reaction in which ionic and polar solution are involved also take place at a higher rate. So we are normally saying if we are having a reaction between an ionic and a polar solutions, reaction rate sometimes will be higher. But this one definitely looks at how is the property of that specific reactant is for it to make the reaction to be slower or faster. Now, before we go to the Maxwell-Boltzmann curve, I will give you a 5-minute breaks just to try and see whether the factors that we have already discussed in terms of the factors that increases the rate of reaction are being understood. So just try to check whether you can understand these factors. If you have any question, please feel free, as I said at the beginning of the lesson, to contact us on our WhatsApp number, which is 064 748 8913. So from now, before we discuss the Maxwell-Boltzmann curve, we'll just take a 5-minute break just for you to vent a little bit. We are going to take a 5 minutes break. Thank you. Welcome back, grade 12s. Remember, this lesson is proudly brought to you by Gauteng Department of Education in collaboration with the Bono Discovery Center, and it is streamed by Pagama Research and Development. We are now going to continue with our lesson. Now, before we continue with our lesson, I think we have already seen how different factors can affect rates of reaction. And we know that the factors that we're discussing, they were all affecting the rate of reaction in terms of increasing the rate of reaction. Now, we are going to look at the Maxwell distribution curve, where we are going to look at how are the particles distributed in terms of the reaction. This curve will assist us to know which region represent what type of particles or what type of energy of particles. When you look at our graph, we have A, B, C, D, and E. When you look at the particles at A, particles at A have there are few particles with very low energy, meaning that at A, particles are having a very low energy. So we look at B, C, and D. There are most particles with moderate or average energies in area B, C, and D, this area. And then when you look at area E, you will see that only some particles under this part of the graph with enough high energy to react. So the number of particles represented by this area here are those ones that do not have sufficient energy to react. So it is very important that you understand in which area or which region on your graph will represent what type of particles or particles with what type of energy. Now we are going to look at the change in temperature. What would happen if you change temperature? You see, when you look at graph 1 is when the temperature is not changed, which is T1. After changing the temperature, how will the graph look like? That is very important. So what I want you to check here, I want you to check on how will the graph react after one of the factors is being changed. And remember, for this Maxwell distribution curve, we are only going to look at the change in temperature, the catalyst, and the concentration. So it is very important that you understand the three. So after you have changed the temperature, after you have increased the temperature, you will see that your curve becomes a thicker. It means it will shift to the right a little bit. So it means T2, which is our graph T2, it has shown that there will be the graph is gonna drop, meaning that as you compare it with the first graph, which is T1, the graph after increasing the temperature, the graph is gonna drop in terms of the activation energy. It means that it's gonna be a little bit lower. And what will gonna happen again? It means it will move slightly to the right. This is exactly what is happening. This is the first graph. The T1 represent before we change the temperature. T2 represent after we change the temperature. And you can also look at the region where the particles or the activation energy is represented. You can see that now the particles here, we have in graph T2, we have more particles. If you can just check here, if you can refer to the graph, this region is higher than the first region. So there are more particles represented on our T2, on our second graph, after we have increased the temperature. And we know why. Remember, in terms of increasing the temperature, we know that we are increasing the activation energy of the particles. Therefore, there will be more particles with sufficient energy to collide or to have sufficient effective collision. Therefore, you'll see that there will be more particles on the second graph, and the graph will move slightly to the right. So what is important is how does, after changing the temperature, how will your graph look like in terms of in terms of being lower than the first graph, and also it will slide to the right, and also there will be more particles in the second graph, meaning that it shows that there will be more, the more particles will have higher activation energy than the first one. So this is the graph that represents the change or the increase in temperature in terms of the Maxwell-Boltzmann distribution curve. Now, what happens when you change the concentration? Remember, these regions also represent the two graphs. When you change the concentration, what will happen? Graph 1 represents the lower concentration, therefore there will be less particles. So graph number 1 is this one. This one represents when the before we increase. And you can see that it's that here. Before we increase the concentration, this is how our graph look like. After increasing the concentration, graph number 2 will represent when now the concentration is high and there will be more particles per unit volume. So you can see that they all start here at the same point, but graph number 1 will be lower, which represent the lower concentration. Graph number 2 will be higher, which represent higher concentration. And also you can see that in graph number 2, there will be more particles that exceeds the activation energy. So it means now that the particles in graph number 2 are going to be more than the particles. The particles with more energy in graph number 2 are going to be more than the energy, the particles in graph number 1 that represented lesser energy. So the graph for the higher concentration shows that an increase in the number of particles whose energy exceeds the activation energy. So in graph number 2, you can see that now the particles are more and shows that they will be they will exceed the activation energy. So there will be more particles with more energy. So there will be more effective collision per unit volume as you are going to increase your concentration. So it is very important to look at how does the temperature affect the rate of reaction in terms of representing the particles after you have increased your temperature, making sure that the second graph is lower than the first graph in terms of the height, and also the second graph slightly moves to the right and there will be more particles on the side where the concentration has been increased. So it means now they will exceed the activation energy. And then in terms of the concentration, because the two graphs, they will sometimes look alike, but they are definitely not the same. The other one, where there is higher concentration, the graph will be higher than the first one, but they both start at the same point. And another thing, there will be more particles on the second one. Now, when you add the catalyst, addition of the catalyst, remember, the catalyst will only represent the lower activation energy. So what will happen? There will be particles with not enough. In this region, there will be particles with not enough reacting energy. However, as you increase the particles, you will see now that these extra particles have enough energy now in this region of new catalyzed reactants, and therefore the original of the particles under this region will have higher and enough energy to react in this region. So in terms of the catalyst, you will just see that the things that will be lowered is the activation energy, and there won't be any change. So that is why when you look at the catalyst, okay, let me just go back. When you look at the catalyst, you can see that the only thing that will change here is the activation energy. It won't change any, it won't move any graph, it won't move any, it won't lower any, the two graphs will not be different, but what will you do? It will just lower the activation energy and there will be more particles with enough energy. So the three graphs that I've just explained are the graphs that show how the particles energy will be distributed or will be changed after you have changed the concentration that I've discussed, which is temperature, concentration, and catalyst. Now, when you look at this graph represents the reactants. As I started, I said for every reaction to occur, the first thing that you have initially is the reactants. So what will happen? This is the graph of the concentration versus the reactants. So what is happening is that the concentration of the reactants, as you start the reaction, you will be having reactants. As the reaction proceeds, the reactants will start to decrease in terms of the concentration. I think we have explained. We have explained that the concentration of the reactants is decreasing because the reactants are starting to be used up. So the concentration of the reactants will decrease. If you look at this graph, the reactants were between 0.30 and 0.25. So it may be there with 0.27 somewhere here. As the reaction proceeds, now the reactants are starting to decrease as the time interval increase. And then you will see that at the end, you will end up sometimes having no reactants because the reactions are definitely going to be used up, because these reactions that we are talking about here are the reactions that are occurring at an open system, whereby at the end of the day, the reactions will be used up and the reaction will stop. So this graph is very important that you understand what happens to the reactants concentration as the reaction proceeds. Now, this one indicates the concentration of the product as the reaction proceeds. So we know that the concentration of the product as the reactants increases, the concentration of the product will increase. as the reactants decreases in terms of the concentration, the products are forming and their concentration is increasing. So these two graphs, they are very important because you need to interpret, you need to be able to say what happens to the reactants as the reaction proceeds and what happens to the concentration of the product as the reaction proceeds. So it is very important that at the end of the day, what we are going to be left with are the products. That is why the product will start from 0 with no product, and they will increase up to where you have the reaction stops, up to where you have enough or the maximum amount of product that you have formed according to that specific reaction. Now, this is almost the same thing that you have explained in the other graph, whereby we're explaining how will these particles be distributed as you are increasing the factors or as you are changing different factors that affects the rate of reaction. Now, this one is exactly what I was explaining in terms of the catalyst. This one, as you look at this one, it is one of the examples that you can use in terms of explaining the catalyst. When you look at this, you see when you look at these two reactions, you can see they start at the same time and they will end at the same point. As they start at the same point and end at the same point, it shows that there was no involvement of a catalyst, but what the catalyst did, it only increased the rate of reaction. So you will see that the first graph is without a catalyst, and then the second graph is when there is a catalyst. So what a catalyst has done, a catalyst has just removed or has lowered the activation from here to this point. So it has provided an alternative pathway for the reactants to react. It has just lowered the activation in it. So this is the graph that you can also use as a representation of how can a catalyst affect the rate of reaction. It has just lowered the rate of reaction. It didn't change any heat of the reaction, and it was also not involved as part of the product in the reaction. It just changed the rate of reaction by lowering the activation energy. So the graph is lower than the other one, but the two graphs start at the same point and end at the same point. That is very important. Okay. This is also explaining how can we increase, like this graph, it shows how can a product increase as the concentration of the product increase as the reaction proceed. So it is very important that you know that this explanation here is just talking about how will we increase, how is the product concentration increases as the reactants are being used up, or as the concentration of the reactants is being decreasing. What I want us to do, I want us to look at this activity quickly so that we can see that the terms that we are discussing are the terms that we can understand in terms of how the examiner can ask questions. This one is just a one-word answer. This one-word answer will assist us to check whether we can remember the bullets that we have discussed in our previous slides. The first thing that you are asked is write down the word or term for each of the following description next to the question number. So the first one says the change in concentration of the products or reactants per unit time. So you can see that there is a change in concentration of products or reactants per unit time. So immediately when you see such question, what comes into your mind? You will go back and check what is it that is explained by the change in concentration. But my main point is not about you understanding the change in concentration. It's also understanding how does the concentration of the reactants and the concentration of the product changes as the reaction proceed. So we know that the concentration of the reactants as the reaction proceed, it will decrease, and the concentration of the product as the reactants proceed, it will decrease. Therefore, this is a definition for the rate of reaction. I will definitely urge you to make sure that you know how the two concentration changes, because it will also assist you in terms of calculating of the rate of reaction, because you will also know when do you use a negative sign, when you don't use a negative sign. And we have explained that we use a negative sign when we calculate the concentration of the product, or the number of moles of the reactants, the number of moles of the reactants, the mass of the reactants, because as the reaction proceeds, the reactants are being used. They are being used, and as they are being used, their mass and the concentration and then the number of moles will definitely will decrease. Therefore, at the end of the day, you'll find that the number of moles that you started with are less than the number of moles at the end. Therefore, it means now when you calculate your rate of reaction, you will end up having a negative value. So that negative value will assist us in order for us to be able to get the positive rate of reaction. So the first answer is going to be our rate of reaction. Rate of reaction. When you look at our second answer, a substance which speed up the reaction, but is chemically unchanged at the end of the reaction. I think after discussing all the factors that affected the reaction, we have also talked about one of the factors whereby when the reaction occurs, it doesn't undergo any permanent change, or it doesn't change in the reaction, or it is also not involved in that reaction. But what it does, it only affects the rate of reaction by increasing the reaction rate. And we said that substance is gonna be a catalyst. And we also discussed that our catalyst must always be a suitable catalyst for us to have the reaction speed up. The minimum energy or amount of energy needed for the reaction to start. Minimum amount of energy needed for the reaction to start. I think we have also discussed different energies, but we know that for every effective collision to occur, we know that we need sufficient energy, and that energy is referred to as activation energy. So activation energy is the minimum amount of energy needed for a chemical reaction to start. What does activation energy do? Activation energy will allow effective collision. And then intermediate short-life group of atoms before they react to form a product. I think we know that these intermediate short-life group of atoms that are there before the products are formed, they are going to be our reactants, because they're the ones that will start the reaction. They're the ones that will be there initially before the reaction starts. Then we have our reactants. And then theory that explain the factors influencing the basic theory of the rate of reaction depends on how they often energetically the reacting molecules. So that theory, I think we have explained it as our collision theory. So this will just assist you to remember the terms that we have already discussed in terms of this lesson, and also make you to be in your toes to know all the factors that are needed and the definitions that are required out of you for you to understand this topic. Now, let's look at how normally these questions are asked in our examination. When you look at this question, the first thing that you look at is your statement. And in this statement, you are also provided with a graph. Now, before we can go further, you must familiarize yourself with the following graph that is provided to you. And when you look at this graph, you must ask yourself whether this particular graph represents your product or represent your reactants. In our previous, we have seen that the graphs that was, let me just go, okay, here it is. We have seen that when we are looking at the concentration as the reaction proceeds, we have seen that the product concentration decreases, because initially there were products and the concentration of the reactants decreases. Initially there were only reactants and there was no product. As the reaction proceeds, now the concentration of the product starts to decrease. Now this one, it was the graph that was representing our product, because we know that we started with no product, but as the reaction proceeded, the product concentration started to increase. Therefore, when you look at the question that is provided to us, already you can see that definitely by the shape of this graph, it shows that we started with 0 volume of carbon dioxide, but we ended up with X volume of carbon dioxide. So it shows that initially there was no carbon dioxide, but as we proceed, there is carbon dioxide. So it means here our carbon dioxide is our product, and this graph represents what? It represents the product. The graph that represents the concentration or the volume or the number of moles of a product. Now, let's look at the question. The reaction of 15 grams of impure, you see, immediately when they are saying it's impure, what comes into your mind? Obviously, if a substance is impure, you must ask yourself in terms of the concentration of that substance. Is that substance highly concentrated or lower concentrated? Immediately when there are impurities, obviously the concentration will be affected. So the reaction of 15 grams of impure sample of calcium carbonate, which is CaCO3, with excess hydrochloric acid, HCl, of concentration 1,0 mole per decimeter cube, is used to investigate the rate of reaction. Now, immediately when you look at this question, the first thing that you can ask yourself is that this is an experiment. And in this experiment, what are we doing? We want to investigate the rate of reaction or the reaction rate. Therefore, it means our reaction rate will be our dependent variable because it's what we are dependent variable because it's what we are investigating. Always, for every experiment, be in a position to identify your dependent and your independent variable. And then the sample of impure, whether it's impure sample of carbonic acid will be your, and the concentration of your hydrochloric acid will be your dependent. So the concentration of hydrochloric acid here is going to be your independent variable, because we know that concentration is one of the factors that affects the rate of reaction. Now, calcium carbonate reacts with 2 moles of hydrochloric acid to give you 1 mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide. The volume of carbon dioxide gas produced is measured at regular intervals. A sketch graph representing the total volume of carbon dioxide gas produced as functional of the time is shown below. So this graph represents the volume of the carbon dioxide gas produced as the time interval proceeds. Now, as I said, the first thing that you need to know, you need to firstly try and check what is it that you understand about this graph. And you can see that obviously when we start, we'll have what? Our calcium carbonate and our hydrochloric acid. So it means these two are our reactants. This is what you had initially before the reaction started. So it means you started by having calcium carbonate and hydrochloric acid. As the reaction proceeds, now you started to form calcium carbonate, water, and carbon dioxide. And immediately when you look at carbon dioxide, you can see that carbon dioxide definitely falls on the side of the product. That is why, as I was saying, that our graph here will definitely represent our product, because it represents the carbon dioxide volume, which is part of the product, which is a produced substance, because it's going to be a produced substance as initially it was not there. So it is going to be formed as the reaction proceeds. Therefore, we started with no volume of carbon dioxide, but at the end we have X volume of carbon dioxide, and at T3 we have maximum volume. So the volume of carbon dioxide was increasing as the time started to increase. And you can see that the graph as it is not a straight line graph. It is showing different steep in a graph. It shows different sharpness in a graph, meaning that as we start here, our reaction is faster. Here our reaction is at a faster rate, and then it starts now to, at this point, it starts to decrease. So you need to know, what does this mean in terms of the steepness of the gradient of the graph. As the gradient is steeper, it indicates that now the reaction rate is higher or is faster. The reaction, or the way the reactants are reacting, they are reacting at a higher rate, meaning that they are still having sufficient energy and there are more reactants. But as the reaction proceeds, the reactions are starting now to be used up, and then the reaction rate starts to decrease until the reaction stops. Here our reaction has stopped. What does it mean? It means our reactants have been used up. You need to differentiate between the two, because as we are going to do the next topic is going to look at the reactions that are proceeding even after they've reached a certain state. So here we are only looking at the open system, whereby after the reactions are being used up, the reaction stop, because we are dealing with an open system. So at T3, we can see now that we have a higher volume of carbon dioxide gas, because that's where now we have reached our maximum point at point X, whereby our volume is X. Now, what are the questions? The first thing that they say, they say define the reaction rate. I think by now we can be able, all of us, to define reaction rate. Actually, I'm expecting each and every one of you to be able to get these 2 marks whereby you need to define reaction rate. So we know that in our one-word question, we were provided the definition of reaction rate. However, our examination will definitely, if they're not going to underline it, they will ask it like this: define it, define reaction rate. So you know that is the change of the concentration of the product or reactants per unit time. If you just say the change of the concentration of products or reactants, you are not going to get 2 marks. You need to also indicate that that will occur per unit time. So reaction rate for 2 marks, you know that is the change of the concentration of product or reactants per unit time. And I into details explain how is the concentration of the reactants going to change and how is the concentration of the product going to change, by explaining that as the reaction starts, the concentration of the reactants is going to decrease as the concentration of the product is going to increase. So that will give you 2 marks for explaining or defining reaction rate. Then number 2 say, give a reason why the gradient of the graph decreased between time T1 and T3. Okay, let me just go back to my graph. If you look at time T1 and T3, according to is it T2? Let me just say, between time T2 and T3, the graph starts to decrease. Now, what makes the graph to decrease at time T2 and T3? We know that at the beginning, the reaction will start at a very high rate because we have sufficient reactants that can react with sufficient kinetic energy or also with higher concentration. But as the concentration, because we said, as the reaction starts to proceed, the concentration starts to decrease. And you know that now, as the concentration of the reactant starts to decrease, what will happen to the reaction rate? The reaction rate will now start to also decrease. Therefore, between T2 and T3, it shows that now the reactants are now being used up. They are starting to be used up because now, as they were being used, as the time proceeds, now their concentration was decreasing. And when you look at between time T2 and T3, that's where now you see that now is where you are going to get your maximum volume of carbon dioxide that will be formed, which is your product. So it shows that now the reactants now are starting to be used up, or the concentration of the reactants, it has decreased. So you can say the concentration of the reactants has decreased, or the reactants are being used up at that point. The next question says, changes in the graph between T1 and T2 are due to the temperature changes within the reaction mixture. Is this reaction exothermic or endothermic? I think I have said before we start this topic, we need to remind ourselves what is endothermic reaction, what is exothermic reaction. So when you look at the graph between T1 and T2, they are saying now there is a change in temperature between this graph. So what happened between T1 and T2? You can see now that it means between T1 and T2, there will be the release of energy. And as the energy is released, it means there will be an increase here of the temperature. So what is happening here is that now the energy is starting to, the graph is a little bit steeper as compared to here. So it means now there will be energy that will be released in this reaction. Therefore, this will favor our, okay, let me just go back. This will be our exothermic reaction. And I think you will further understand this because this reaction, as it's going to occur, definitely there will be energy that will be released in the system. And as the energy is going to be released in the system, so they are saying, explain this by referring to the graph. You must refer to the graph. Now, what is important now is that they are saying they are changing the temperature. And as the temperature changes, what exactly are we doing in the reaction? What exactly are we doing? First of all, we know that an increase in temperature will definitely increase the rate of reaction. Therefore, in terms of the temperature now, as I'm going forward, in terms of the temperature, what exactly are you doing? We have seen that the gradient is has increased. And this shows that as the gradient has increased, it shows that the rate of reaction is increasing. The gradient here has increased. And then as the gradient is increasing, because as you compare this point and this point, this one is sharper. If you can look at the question, it's sharper. And this sharpness shows that there was an increase in temperature. The examiner didn't tell you how was the temperature changed, but the shape of the graph is the one that told you that, no, at this point, between T1 and T2, the temperature is increased because now my graph is becoming steeper. So as the graph becomes steeper, it shows that the rate of reaction is increasing. And what factor, what is it that you must do to the temperature for you to increase the rate of reaction? You must increase the temperature. So the graph here is steeper because there will be an increase in temperature. And as the temperature increases, there will be the rate of reaction will increase, and then the energy will be released. So as you are increasing the temperature, the steepness of the graph will increase, or the gradient of the graph will increase, or it is steeper. You know, sometimes you can say the graph is steeper than before, showing that the temperature has increased, and therefore there will be energy release, or the temperature increases and the rate of reaction will increase. So it is very important that you look at the shape of the graph and you know how will that steep or how will that change affect the rate of reaction. If it is less steeper, it indicates that the temperature is decreasing. But if it is more steeper, it indicates that the temperature is increasing, and therefore there will be energy that is going to be released and the reaction rate will increase. Now, let me just go back to the question. Now, we are not going to discuss 5.4 because this one I will definitely make sure that as we are going to discuss it, we are going to start by referring to our revision of stoichiometry, because I know that sometimes when you having the revised stoichiometry, you might find that this becomes a challenge to you. So as we are going to discuss our stoichiometry in our next lesson, we'll definitely go back and do 5.4. 5.4 now talk with about percentage purity. Remember, as we started this reaction, we started with impure calcium carbonate. And we must know that immediately when we change the purity of a reactant, how will that affect the rate of reaction, or how will that affect our reaction as it proceeds? So this one, it deals with percentage purity, which we're gonna discuss definitely when we are going to do our stoichiometry, because we are going to have a fully fledged lesson on stoichiometry, on how do we calculate this percentage purity and the percentage yield. Now we are going to go to our 5.5, which is our next question, because I just want us to focus on the factors that affect the rate of reaction and how are the concentration of the reactants and the product changes as the reaction proceeds, which is going to be 5.5. So they say, how will the rate of reaction change if 15 grams of pure sample of calcium carbonate reacts with the same solution of HCl? What they have changed here, they've changed the purity of the reactants. Before we started with impure calcium carbonate, now they are making this calcium carbonate to react with now they are making this hydrochloric acid to react with a pure calcium carbonate. So you can think about it even on your own to say, how will this purity affect the rate of reaction? Remember, they haven't changed the concentration of the hydrochloric acid as one of the reactants, because as I said at the beginning, when you change the concentration, you change the concentration of the reactants. We cannot change the concentration of calcium carbonate because it's a solid. Remember, you can't change the concentration of the solid, but you can only change the surface area of the solid, because I have explained that in terms of the concentration, it can be the concentration of the gases, it can be the concentration of the liquid, but it cannot be the concentration of the solids. So you can't change the concentration of the solids, but you can only change the concentration of the aqueous solution. Now, If you use the same concentration of hydrochloric acid, which is our reactant that we are going to change their concentration, we are going to increase the concentration of the hydrochloric acid or decrease the concentration of the hydrochloric acid because it's our reactant. But in this particular question, we are not going to change the concentration. We are just going to change the purity of calcium carbonate. Now, if we change the purity of calcium carbonate, we'll definitely expect our reaction rate to, we are saying now, remember we are to increase. Let's go to the next one. Immediately when we change the purity, we are expecting now our concentration, our reaction to increase, because the more the pure the substance, which is a reacting substance, the higher the reaction. So it's extreme as if we are concentrating with the concentration of what, of calcium carbonate in this case. However, we are not concentrating in the concentration of calcium carbonate, but we are only looking at how will it react when it is impure and how will it react when it is impure in terms of the concentration, the same concentration of hydrochloric acid. So we can see that now immediately when we change the purity of calcium carbonate, we are also increasing the reaction rate of this reaction, because there will be more particles with correct orientation, and then there will be more effective collision per unit time. So changing the purity will make this particle to have a correct orientation, meaning that this is about what? Is about the nature of the substance, or is about the surface area of the, because there is something that is being changed out of that solid, and we know that solids will definitely affect our surface area. But if there are impure substances within that solid, definitely it will make our reaction rate to be slower. So my learners, I think by explaining this example that I've just done without looking at that calculation under stoichiometry, we are in a position to come and answer questions that are asked under this topic of rates of reaction. So what is it that we've started with? We will just go back and look at what is it as we are consolidating our lesson, because it is very important that we see what is it that we have done as we started this lesson up to this point. We started by looking at, let me just go back. We started by looking at different definitions, and those definitions, we could see that definitely we were supposed to know them, because these are the definitions that will affected our lesson. We started by looking at exothermic reactions and endothermic reactions and kinetic energy, and we defined what are those energies and those reactions. We also look at different types of bond energy and bond lengths, because we are dealing with chemical reactions whereby sometimes bonds will be formed, sometimes bonds will be broken. So it was very important for us to understand and go back and understand this type of bonds. And then we also looked at activation energy, which is the minimum energy required for this reaction to occur. And we also explained that without sufficient activation energy, no chemical reaction will occur, because activation energy provides effective collision of particles in a reaction. We look at chemical reaction in totality by saying immediately when you start the reaction, the only thing that you have are the reactants and there are no products. But as the reaction will start to occur, we will see that the number of products will start to disappear by decreasing the concentration or the mass or the volume, and then the number of products will start to increase as they are going to be formed. And we also look at how is the reaction occurring in terms of chemical bonding, because we understand that in terms of the reactants, the bonds on the reactants will be broken so that the bonds on the product will be formed. So I explained the activation energy already as the minimum energy. So you must make sure that you know that if you know the energy that is required for the reaction, if the energy is less than the activation reaction, you must know that that reaction will not occur. The energy must be equal to the activation energy or more than activation energy. We also look at how do we calculate, we define the rate of reaction as the change in concentration of the reactants or products per unit time. This definition was explained to you thoroughly, and the changes on the concentration of the products and the reactants was also explained. We also looked at how do we calculate the rate of reaction. whereby we also explain what is the significance of this negative number. We said we use a negative number if we calculate the number of moles or the mass or the volume or the concentration of the reactants, because the reactants are going to be used. And as they are going to be used, it means finally they will have a lesser value. So now for us to have a positive rate of reaction, we must make sure that we include a negative sign. Then we also look at when now we are calculating in terms of the product, you must make sure that you don't include a negative sign, because the product are being formed. At the end of the day, the final product that is there is going to be higher than the initial product. Then we also looked at collision theory. In terms of the collision theory, we look at the three conditions that will make the reaction to occur, which is effective collision, which is sufficient activation energy, and correct orientation. So we have already seen that if the orientation is correct for the new atoms to be formed, therefore the reaction will definitely occur. And also if there is sufficient activation energy and there is also enough effective collision of particles, definitely that reaction will occur. We also looked at the factors that affect the rate of reaction. And it is very important that you are not confused about any change that the examiner can give you which doesn't affect the rate of reaction, because these are the only factors that are being considered to affect the rate of reaction. These are the factors that when you want to increase the rate of reaction, these are the factors that you need to change, or these are the factors that will influence the increase in terms of reaction. Why am I always referring to increase? Because we are only looking at the factors that will increase the rate of reaction. We looked at each and every factor. In terms of the surface area, we said there will be more reaction sites, there will be increase in the frequency of total collision, and there will be more effective collision per unit time. And I said to you, make sure that all the bullets that we have explained today are part of your explanation as you're going to explain in terms of the collision theory. We also look at the concentration. How does the concentration affect? And we also explain further that in terms of the surface area and the concentration, we only change the surface area and the concentration of the reactants. And in terms of the concentration, we change the concentration of the aqueous solution. So we said the higher the concentration, the higher the reaction rate or the rate of reaction. And what is it that we are doing? We are increasing the number of solid of particles in a solution per unit volume, and we are increasing the effective collision between the particles that are colliding effectively. And definitely the rate of reaction will increase. In terms of the temperature, we are now affecting what? In terms of the temperature, we are affecting the average kinetic energy. So the higher the average kinetic energy of the colliding particles, the higher the temperature, the higher the rate of reaction. And we know that for every molecule to have minimum energy, we must have higher activation energy. Therefore, there will be more effective collision per unit time and the rate of reaction will increase. But definitely we need to see that when we increase temperature, we are increasing the average kinetic energy of the colliding molecules or particles. We also said we are going to add catalyst. We are not going to increase the catalyst as we increase the concentration and also as we increase the surface area. We are now going, and the temperature, we are now going to add a suitable catalyst. So for every suitable catalyst that we are going to add, we are going to increase the rate of reaction. And what will happen to the catalyst? The catalyst will not change in terms of itself having a permanent change in the reaction or participating in the reaction, but it will only provide an alternative pathway for the reactants to react. And as it provides an alternative pathway, it will lower the activation energy. And as it lowers the activation energy, it will increase the rate of reaction. Therefore, there will be more effective collision per unit time. Then the nature of reacting substance, I think we also explain it to say the nature of reacting substance depends on what is reacting in terms of the properties of those reacting substances and the medium. We looked at the Maxwell distributing curve. We look at how are these particles distributed as we are changing each and every rate in terms of the energy that they will have after changing the factors of that affects the rate of reaction. This one it was the graph that was representing the temperatures, whereby both graphs will start at the same point, but as you increase the temperature, the other graph will be lower than the other one, and the graph will shift to the right. And what will happen also, the particles will now have more sufficient activation energy after the graph after we have increased the temperature in that specific reaction. And then for the concentration, both of them also start. This is very important because you must also always make sure that they start at the same point. Because if they start at the same point, it shows that this reaction, the only thing that you have changed is the factor that affect the reaction. You haven't changed the reactants. So they will start at the same point. But when you increase the concentration now, the other graph will be higher than the other one, and it will also indicate more molecules with higher activation energy. And then after adding the catalyst, I want to use this one because the catalyst one, I think, is nicely explained with this one. The catalyst will lower the activation energy, making sure that there's an alternative pathway for the reacting substance to occur. But the two graphs will start at the same point and they will end at the same point, unlike the two graphs that I've just discussed with you in our previous slide. Then we also discussed the graph of the concentration versus the reactants. Today, as the time proceeds, what happens to the concentration of the reactants? And we've seen that because we are definitely going to start with a high number of reactants, as the reaction proceed, the concentration of the reactants will start to decrease. The reason is because the reactants are now starting to be used up. Even if you are dealing with the mass will decrease and also the volume will decrease. So it doesn't matter whether this side you find the concentration or you find the mass or you find the volume. What is your expectation is that all those variables must decrease in terms of the reactants as the reaction proceeds. Then, in terms of the products, we are expecting that in terms of the product now, the concentration or the mass or the number of moles must increase up to where the reaction stops. So we know that we'll start with no product at the beginning, but as the reaction proceeds, then the product will be formed and the concentration of the product will be formed. And we also need to be able to interpret different gradient of the graph in different time intervals. Then we looked at, okay, let me just go forward. This was the explanation of what was definitely happening in terms of the increase in terms of the products, of the concentration of the product as the reaction occurs. Now, my learners, I think we have come to the end of this lesson. I hope that as we are going to proceed to the next topic, you will be in a position to take this information that we have done today and link it with the next lesson that we are going to do, because it is also about the reaction. But now in that lesson, we are not going to look at the reactions of an open system. We are going to look at the reaction of a closed system. Now, by so saying, I would like to say thank you so much for watching this lesson. Please remember to sanitize and wear your mask, maintain your social distancing, and keep safe. Until I see you next time with our another lesson on chemical equilibrium, it's cheers for me. Thank you so much.